Good morning and welcome to the track. I'm going to talk today about why servers are dead and long live the service. I'm sure a totally uncontroversial topic where we're all on the same page on everything. So let me just start by introducing myself briefly. I'm the CTO at CodeShip. CodeShip is a continuous delivery service. We test and deploy software for thousands of teams, basically CI and deployments or continuous delivery in the cloud. That's where a lot of these ideas come from. More importantly, this is CodeShip. This is all the people that work on, or most of the people that work on CodeShip, and was done 2 weeks ago at our company trip to the Tyrolean Alps, which was fun. As the Tyrolean Alps might suggest, I'm originally Austrian. That's where my dialect is from, in case anybody's wondering. But because I not just like the Austrian Alps, I get to spend a lot of time in Boston as well. And in the Boston Alps, I don't know if you've heard of that. That's the craziest thing I've ever heard. It's in the MIT space. There is a 5-story, or I think at the highest it was 4 to 5 stories high, mountain of snow. And I'm really looking forward to see that. So my colleagues think that it's going to be around till June, which is even more crazy. So yeah, just to briefly go over how I want to structure the talk. So I'm gonna share my thoughts first, and then I really want to go into QA. But I also have a couple of questions to you regarding this, because I mean, as I mentioned, this is not just a controversial topic, but very different thoughts on that. So I really want to get your thoughts on many of these things as well, and how you deal with these problems. So let's get started. As obviously everybody of us knows, and as is reported constantly, software is really touching everything at this point. There's every industry, every new market is touched by software, or software is at the base of these markets. It will be and is already transforming so many different industries. And I mean, just look at Netflix, completely, and HBO and others. They're completely, with their new HBO everywhere now, it completely eats into TV. Uber, it's probably transportation, not just taxis, but everything. And yeah, Amazon does anything anyway. But at the core, they're software companies. At the core, what they do is build software and a software product. They don't come from the other side. They haven't done films in the past and then done software. That's why all the other teams are struggling, or all the other products are struggling to keeping up with Netflix or the HBOs. So they're with Netflix specifically, because that's what they do. They do software really, really well. And there's this constant pressure on every company and every product out there. Market and competition comes out with new products, new features. And then when they come out with new stuff, your customers want those new features as well. So you get pressure from them as well. Then obviously, team, process, and technology changes constantly. I mean, the technology that we've used 6 months ago is theoretically already out of date, although it's going to be used for a long time. And processes, new people coming into the team, leaving the team scaling a lot. So that's all pressure that we need to deal with constantly. And even just in the last 2 days, there were 2 blog posts, one of them from at the NGINX blog about Netflix. And I think for me, one of the biggest takeaways from there was that optimize speed and not for efficiency. Like Netflix and a lot of these software companies really understand is that you need to move fast. You need to be able to use those pressures, as described here, and incorporate them into your product quickly to understand that whole lean startup model, that lean MVP model, but then really moving fast and as fast as possible. But also one blog post by Steve Blank, about why the fear of failure and how fear of failure is different in startups and large corporations, and how fear of failure drives startups to just be faster, because failure means you're dead, basically, as a startup. On the other hand, in large corporations, failure is when you have an existing product model and market that just works. Failure is when you don't do the same with a new product. And I think the same here, that we need, in small as in large corporations, we need to come to a place where we are as fast as possible. Because software and how it changed, how each product is built, touches large companies as well. As I mentioned before, all the CNNs in the world and all the other ABCs probably didn't expect Netflix to eat their lunch. And it's happening. And I guess most of you aren't watching TV as much as they did in the past, if you even watch TV anymore. So I think the biggest change that is happening now is that we need to differentiate through software development and not just better software. Better software is getting outdated immediately. You have a great product, you put it out there, and you aren't fast enough to improve it in the future. It's already outdated, you've already lost the market in many instances. So that's something where I think that shift is definitely happening a lot now. One great book that goes into detail on that is The Phoenix Project, in case you read or haven't read about that. It's one of my most favorite books. I try to read it like every 6 to 9 months, and it's great for everybody, especially when you come new into management or developer management, which I have over the last couple of years. It's an awesome book and really, really interesting. So on the one side, we're confronted with that everything moves so fast. Every product moves so fast. There's new people coming in all the time. And we need to move faster. We need to build more. On the other hand, there's a total lack of great software engineers or software engineers in general. Just raise your hands if your team or your company faces the problem of hiring and finding enough good software people. If there's one hand that isn't down there, I think you're lying. So I think that's a massive problem that we have, is that finding the right people with the right motivations and being able to move fast forward is really, really hard. And like there's many different ways, and like one of them is also that we're doing not really a very good job in building a very diverse community, which like limits the number of people that generally come into that space as well. That's another problem where we just limit ourselves in many, many different ways. But it's a really hard problem. So we want to move really, really fast, and there's just not enough people to move that fast. And the next thing is that it's not just software that is approaching other markets, but the competition inside of the software industry is even moving faster. Look at Stripe attacking PayPal. Like Stripe is a very new, relatively new, I mean they're 5 years old, payment service that while still being a lot smaller than PayPal, moving very fast into the market. And there's other companies now, even smaller than Stripe, moving into Stripe's market and taking away from them. And that will get faster and faster all the time. Like that won't slow down. And it's not just that we as a software community or we build tools to attack or like to take over markets of incumbents that don't really know software. It's that software industry and everything is software now that we are attacking each other. Attacking sounds a little bit too much, but in the market, that's basically what happens. Like we build new products to take over competition's market. And that hasn't stopped, or that has increased in the software industry itself a lot more. So we have these things, the software is everywhere, we don't have enough developers, and there's lots of competition. If we're in a non-software company or a software company that doesn't see software as its core, or even if we're in a company that sees software at its core of the product cycle. So the result, in my opinion, out of that is that productivity and focus of your existing team is absolutely priority number one. Anything else basically doesn't matter. Like anything you can do to increase productivity and increase focus, and I think both of them go very much in sync, needs to be the number one of any. And I think that Ken yesterday at the keynote made a very good point in that it's the manager's jobs and like the leadership's or management's job to make sure that everything is moved out of the way so the team can fully focus on productivity. And that's not just like company stuff or like filling out forms, that kind of stuff, but also making sure to guide the team and make sure that the team moves in a direction that their technology choices is as productive as possible. I think that's a lot of ways where we still, as an industry, struggle. We're not as productive as possible. Because if we're not focused on the productivity and moving as fast as possible, we just open ourselves up to attacks. We're just leaving a huge door open for anybody to come in and just take our market. And that's just really not what we want to do, because we probably like our jobs, we probably like where we work, and we really want to see that team or that company or that product win. Because it's fun to work on a product that wins. So in terms of the companies and products, we're really in a go fast or go home mentality. I think the problem that we have, and a problem that we often see in the software, in software companies, is that this gets translated directly into go fast or go home mentality on the team level or on the personal level. I think that's a huge issue of we're not working more in many, many instances doesn't yield higher results. Like we won't get a lot faster. We won't get this 10x faster, 10x better, whatever. I mean, there's another problem with that term in general, but we won't get there just by working more. Like we're humans, we're getting burned out. There's a lot of burnout in the industry happening. So we really need to find ways where we're going faster as a team, as a product, without burning out, without making our team go crazy, basically, which happens in many ways, especially in startups, but I think in any industry or any size of a company. So yeah, to go back to what in the Netflix case from that blog post about Netflix, the top lesson that Cockcroft learned at Netflix is that speed wins in the marketplace. That just move fast, iterate quickly, make sure it works, find the next step and the next step and the next step. That's how they won the market, and that's how many others, including in Amazon and Google and others, have really won their markets in many ways. So what is the best way to optimize a specific task? What is the best way to become faster, to gain that focus? In my opinion, and that's, oh, sorry. Can you hear me fine still? Yeah. In my opinion, the best way to optimize a specific task is by just not doing it. Let somebody else do it. That's by far the easiest and by far the best thing you can ever do to become faster. Just stop doing stuff. And I think that that is definitely on a personal level, but also on a company level. We're doing too many things that really don't matter. That we do them because we like to do them, or because we're not really sure about them, or we're not trying to make us focus enough, but we're still doing them. And with all the stuff that I've said before, I think that's a huge issue, because that's one of the biggest places where we can be faster, be more focused. And that's one of the where you can differentiate between go fast as a team and go fast as a person. When everybody works their 40 hours or whatever, like the hours are in that specific team, on the most important things, on only the stuff that really, really, really matters, and really everything else is taken out. And I think everything that we do should be very evaluated on, is this really important? Then we can be as fast as possible without working us to death. So that leads, in my opinion, to outsourcing. Outsourcing, but not in the labor sense, not outsourcing the labor itself and just doing the same things, just having more people or having somebody somewhere else build that. I think one of the experience with outsourcing so far that I've seen or heard in the industry aren't really that good, because if it's hard to communicate in a team locally, it's really hard to communicate in a team that is 5 time zones away. And since we have it, like we work a couple of people in Europe, we have Europe and Boston as our offices. 6 hours time zone kind of works. We make it work, but it's still hard. I'm regularly in San Francisco, and 9 hours time zone between Austria and San Francisco means I don't get to talk to most people in Vienna pretty much all the time when I'm there. Or I'm very tired in the morning, or I'm very tired in the evening, or somebody's always tired. And I hate meetings where somebody's tired. That's just no fun. It just takes a long time. And also on the other hand, I think that many in typical outsourcing countries in the past, like Eastern Europe or even India, a lot of these developers and the best developers there are now starting to either build their own companies or are working to build companies there, or working for good companies there. So it's not just, we're not even getting the best people necessary to that. So outsourcing labor is, in my opinion, something that is basically we have to move past. That's just, it's not going to work in the future, and it's a lot of diminishing returns. So what I really want to talk about is outsourcing to services and automation. Just not doing stuff and letting other people take care of stuff that we generally like to do. Like some of these things are really, really interesting and really fun challenges. Should we really do them? Probably not. And so outsourcing in that kind of ways is really important. And I mean, that revolution has happened. We're in many steps past that. So Judgment Day was here. Our machines are self-aware, and they're doing this now. And how has this, like, what is really that revolution that has happened? It's not virtualization. Virtualization is super old. I didn't know how old it was. I looked it up basically on Wikipedia, and it's basically as old as computers. Like, as soon as there were computers, somebody was like, hey, I want to run this on this. How do I do that? And that was it. That was basically from day one, is a little bit too much, but very early. Also, separation of responsibility isn't new. We've been doing this for a while, having different teams work on different parts of our infrastructures, separating it out. That's not really new. That's not a new thought. The revolution, in my opinion, is the accessibility. We're now at a point where it's relatively low cost to start, or actually it's very low cost to start if you factor in time and the cost of each other's time, for any team size to build very complex infrastructure with basically complete automation. Like the cloud has brought us that to a large degree. I think we're all in some way, like who of you is here is using the cloud, whatever the cloud means specifically, in any meaningful way? So that's about, I guess, half. Who of you plans to use the cloud in the future, or where the team moves there in the future? So that's probably the other half. So that makes my point, hopefully. But yeah, Instagram is, and there's many others, but it's a great example. And I mean, if you go to the AWS conference to reInvent, there's like the biggest companies in the world, and some of the biggest companies there are there like saying, okay, we're moving this way. So it's, in many ways, it's something that is happening and there's no turning back. It's just, this is what it is, this is where we need to go, because we just don't have the time to do all of that on our own. And something that is really important there for us is that we want to make sure that we decouple the growth of our team from the growth of our infrastructure. That means that I don't want to hire more people when I run a larger infrastructure, basically. We just need better automation. I want everyone on my team that I hire, or as many people as possible, to work on product, because product gets me more customers. Product gets me a better product, gets me, in the future, gets me a bigger share of the marketplace. Being able to automate my infrastructure, while it's very important, is non-differentiating work. There isn't, and everybody has to do it in some ways, so it's totally non-differentiating. It has to be good, it has to work well, but that's not how I convince anybody. I can't go out and say, like, we have the best scripts and the best automation in the world to keep our servers up, but yeah, we're missing a couple of features that the competition has. I wouldn't buy that, and probably neither would most people here. I mean, of course, stability is important, so there is a certain threshold that needs to be met, but beyond that, nobody cares. And I think that's really important today or in the future to understand and use in each team. So again, to go back to the Netflix article, they said a single specialist in Java distributed system is managing the entire Cassandra cluster, which for the data storage, without commercial storage or any SANs. Like, there's a much larger piece in the article about that. But basically, they don't care about, they use AWS, of course, so they use S3 and other solutions that AWS provides. So they don't really have to care about the heavy lifting of many of those things. And neither do probably most of you who have raised their hands, and neither do we when we use AWS. Just somebody else does it for us, and we don't have to think about that anymore. And that's one person, and maybe even a half-time person. And the rest of the time can be focused on building product. So it's really optimizing time by dedicating engineering to product. That's not doing stuff that we shouldn't do, and do stuff that actually make a difference. That's still, in my opinion, the biggest factor of how we can improve. And then we can look how we have better processes in place. But if we are really, really efficient in doing stuff that really nobody cares about, then we're not going anywhere. So we want to have the look of infrastructure just being software. Like, it's just software. Of course, for the provider, it's not just software. It's hardware. It's making sure that everything works. But that's not what I have to care about. That's Amazon's problem. It's not my problem. Infrastructure for me is just software, and it's software that classes, and I can treat it like software, like classes that I instantiate and then garbage collect at some point. And I don't have to care about anything else at all. And I want to underline my point with some totally made up numbers, backed by anecdotal evidence, is basically that, and that's something that is more in probably startup, or in our sense, that when we started, automation was a much bigger part of time dedicated to infrastructure development. So that's a blue line, so it's 35 to 75, completely made up numbers, but just to illustrate my point. Over time, and that's definitely happened now and will happen more in the future, we want to have more time focused on product growth and less time focused on infrastructure growth when we grow our team. Because we have to decouple those different teams and those different work pieces from how many people we have and how many customers we have. It shouldn't matter that we have more people, more money incoming, and all that kind of stuff. On the other hand, in a non-cloud environment, from the feedback that I've gotten and done in my past, it's while you can decrease the time you spend on infrastructure, there is a certain level that it just takes time to manage hardware. And many of the things they take time. They just need to be done regularly. It just takes time. It's not somebody else's problem. It's still your problem. And when somebody's still your problem, it just takes time. And that's a massive difference. Imagine 25 to 30% of efficiency or of time dedicated to the product instead of stuff that aren't a differentiator. That's huge. That's the difference between being a competitive company and just not being in a competitive place. And that's really what we try to strive for. But even the less than 5% infrastructure development is not good enough. We want to have less. Doesn't mean we want to have a bad infrastructure. I'm really trying to not say the words. But it's really about making sure the product is the best. And the infrastructure fulfills the expectations of our customers. So now we're at a place where the cloud is working, and we've been using the cloud, and like about 50% here are using the cloud, and it's growing dramatically all the time. What's next? Where are we going now that we have the cloud? In my opinion, and that's the main gist of the talk, it's the service. I like Terminator for some reason. But exactly. There's a new one coming, apparently. So the service. What's the difference between the two? First of all, the cloud is still full of servers, which is a problem, because that's still something you have to worry about or think about. Servers develop personalities. If you run them for long enough, they develop personalities. They have, the worst thing, even some of them have names at some point, so they start becoming pets. They can misbehave. That's the craziest thing ever. Like if you have something that from time to time misbehaves, and you have a conversation about that, and like coming from that is the sentence like log into XYZ, debug and fix issue A happening on that machine only. That's like the biggest red flag there is. That's like, okay, this really like should not be happening, because it just shows, in my opinion, and of course, like all of these things are my opinion, and I'm interesting to look forward to get your view on that. But it shows a lack of data, simply because what else would you be doing when you log into a machine than collect specific metrics or look at logs? There's not really that much else you can do. So you should be able to pull all of that data out, push it to a third-party system where you can debug it in at the same time. You can debug it in a week. You can reference it. You can go back to it. And if you don't have the data for something, add that data and make sure you collect it. Because the problem is that otherwise we'll get to that, I'll fix it here once, and then maybe it comes up tomorrow on the next server, or maybe it comes up there. And there's many tools that are dealing with this, and it's a huge issue that that all of the industry is looking into. But when you still think in terms of servers and long-term servers and something that's running for a while, it just happens because sometimes they misbehave. It's technology. It shouldn't be random, but sometimes it just is random, and we don't know where it's coming from. It also shows a lack of automation, because in many instances, when something is misbehaving, I don't want to repair it. I want to take it out and put something new in that doesn't misbehave. I then want to look at why it's misbehaving, but I don't want to repair it in production, because that's something that impacts my customers potentially. I just want to replace it. And maybe it's something that I don't want to deal with, or that I don't have to deal with, because it's Amazon networking getting slow for some reason, or a noisy neighbor. Pull it out, put another one in, and be done with it. Unless it comes up again and again, then you have to look into it. And also, like, going into a specific server is, at least how we see it, shouldn't not even be possible. We want servers that are locked down, and where all the information comes out of the server as we need it, so we can debug it. But it should just be something that isn't for security reasons, and also to make sure we have the incentive to pull all the data that we want out of it. You might have to jump through a couple of hoops to get in there. Even that is, in my opinion, questionable if that should be possible. But it shouldn't be so easy that it's the first thing somebody does, because then you don't attack these actual underlying problems, the lack of data and the lack of automation there. So I really want to get to a point where we don't care about servers anymore, where servers are irrelevant. The number of servers and everything is irrelevant, because servers aren't notebooks. I use a Moleskine religiously. That's really important. I have a couple of Moleskine blogs from the last couple of years. I cherish them. They're really important to me. They show the progression over like university to working to starting the company and like all this kind of stuff. I never really look at them, but I want to keep them. And I get attached to it. It's important to me. That should not be a server. Servers are Post-it notes. I don't care about a Post-it note. I tear it up and throw it away if I don't need it anymore. A Post-it note in and of itself isn't really worth anything. In combination with many other things, it gives us new ways to show data, to do interesting stuff that a notebook can't. But in and of itself, it doesn't have a lot of value. And I think that is really important. That is what, in my opinion, I prefer that to the like pets and cattle kind of metaphor, because I don't want to shoot anything, basically. I don't know. But it also has other problems. I think that the Post-it notes and notebooks capture further. But I think that's really, really important, that removing anything like the infrastructure, I should not care about it. So the servers just should not matter. It just, and why does it? Like, it's in the end, it's all about the customer experience within a budget. But if I run 5, 10, 50 servers, who cares? As long as I'm willing to pay for that, who cares? And I don't even want to know. Like in many instances, like when we, in our infrastructure, like I can look it up or we can look it up, but there's no time where anybody really knows how many servers are running typically. You have to look it up because we just don't know, because it doesn't matter. The only thing that matters is anything gets stuck in the queue? Do enough builds run? Are our customers happy with that? Anything else, just as long as it's in the budget, who cares? And the amount of infrastructure that you need should be a discussion between our app, our metrics, and our budget limits. No humans involved. Because that's just something that we need to think about, care about, distracts us from like the important stuff that we can automate, like finding out what customers actually want. So set an SLA and just be done with it is really where we're pushing to. So that's more around the like servers and services where I see the difference in that. But what are services actually? Service is a horrible, horrible word because everything is a service. And I still haven't come up with something better. So there's infrastructure as a service, platform as a service, service-oriented architecture, microservices. I'm not talking about any of those. A little bit platform as a service. So what I mean by a service is something that lets me run a minimal set of code to what's necessary for fulfilling one specific piece of work. That's a service. A service like AWS Lambda that came out in case you've played with that in the past. So no infrastructure, just code and dependencies. I really don't want to care about infrastructure or scaling or automated health or any of that at all. I want it to be all about the what and not how. Even something where I have, like on Heroku, where I have to decide which web server I'm running is in many, like there's certainly stuff where I want to have that exact web server and the exact setting. There's many, many cases where I just don't care. It doesn't make any difference at all. Like there's many discussions that we have and many decisions that we take that just don't make a difference. Most of the systems that we run or most of the parts of the larger system are not under constant load and under massive pressure all the time. So small optimizations there probably don't matter. And if somebody else can take care of them and just do a good job with that, awesome. And if you want to, we take it out and run it somewhere else. The communication, that's an important part, is done through the service provider. So I also don't have to care about that stuff. It's just there for me. I need to be able to extend it. I need to be able to go take parts of it out and parts of my infrastructure out and run it somewhere else. But to start, also something I just don't want to care about. And the worst is like scaling the communication. And what I mean with communication is anything between microservices, between the pieces of code. That can be a queue, that can be like through HTTP and all that kind of stuff. But generally, I don't really want to think about that. It should be based on standard languages. Standard meaning something like Node.js or Ruby or Java. Something that isn't a complete lock-in, which, for example, Google App Engine. That's one of the things why I think Google App Engine didn't really work out and wasn't really that competitive in comparison to others, is that you didn't build an app that ran on Google App Engine, you built a Google App Engine app. Has everybody ever worked with Google App Engine? Did you enjoy it? No. Did anybody enjoy it? Because I'm really interested in somebody, like it has scalability and there's like many features that are really nice, but it's their way. And when you have to do it their way exactly, that's a big issue. I think AWS really has understood that. And they're trying to build all the services in a way where you use just a Java framework, or you use Ruby, or you use Node.js, or whatever you want to use. And all the automated scaling, automated healing, and planned obsolescence, I think that's something that is really important, are just done for you. Planned obsolescence meaning you just, once a day, all the servers are flushed, and you get new ones in place, because that really helps with the automation and just remove some of the issues you have when you have a system that really relies on longer time servers. And I know I'm not really helping with that, but I call this microservice as a service. I'm sorry, I haven't come up with something better. I know that's not right to do, but I haven't come up with something better. If you do, please tell me. I hate the word service. Everything's a service. So one of the biggest issues that I've heard with that is login, as I said, with Google App Engine. It's definitely the number one pushback whenever I talk to any kind of tech leadership. It's the number two for developers. Typically the number one for developers that I talk to is keeping an overview in such a system. When you have like tens or hundreds of small services, making sure what runs where and how it is built up is something that is a nightmare for most developers, more so than I've seen when talking to tech leadership, although it's a nightmare for tech leadership as well. So I think what's holding us back and the locking that we see when moving into this new world is around inertia, code level lock-in, and architectural lock-in. Inertia is just, it takes time to move from one place to another, and it'll always take time. Especially moving data is just painful. It's always going to be there. We can make it better. I don't think that we'll ever be at a place where moving from one cloud provider to another will be like the push of a button, not for any meaningful infrastructure. Personally, I don't think that in most cases it's really possible. I really want to see a world where maybe we have some pieces running here, some pieces running there, and it's just the tools are good enough to make sure that we can accomplish all of that with some of the specifics then set up. But just moving between them at a click of a button is just, I don't think that's going to happen. Code level lock-in is the same as in the Google App Engine example, and I think that's one of the things that, especially I hated working with Google App Engine, is that it needed to be their way. And I couldn't just do a little bit here, a little bit there, a little bit differently. It just needed to be their way. And it made sense why it's their way for that specific setup, but then a lot of people just didn't want to use that, which I totally understand. So yeah, Google App Engine, in my opinion, got that wrong. I think that's why Google and the cloud services are moving in a very different direction now with all the other stuff that they support. So building on top of standard frameworks with Lambda starting with Node definitely makes sense there. And I think that when you look at infrastructure and how infrastructure evolves, starting somewhere where you don't need full control over every part of your infrastructure in the beginning, you can slowly move parts of it out and move it into something that has more control. For example, starting with more Lambda stuff, then taking it out, running it in an AWS server directly. If that doesn't work, put it into your own data center. I think that those levels of control, when we start with, we need all levels of control, or even we need like that mid-level of just our AWS EC2 instances, just isn't as effective and as productive as it could be. And I think making sure that we build something in the beginning where we can move out of it, but we can leave a lot of stuff there because we don't care how exactly it's run, is a much better way to go in the future. We're doing it. We'll see if it works out in the longer term. So far, we're really happy with that approach. Then, of course, there's architectural lock-in. A lot of these things are assumptions, just as an FYI. Small code base is easier to move. That's somehow, I don't want to say proved assumption, but something that definitely we see in some way, that small services that don't do a lot of stuff are just easier to move somewhere else because they have typically small data sets with them. They're not as complex to run, so it's easier to move it to take one function out of Lambda, use the same Node.js code, and run it on your EC2 infrastructure or on your EC2 server directly because you want to have more control of it. Of course, it's a little bit of work around that, and you need to do more stuff around that. But that's something that the assumption is that is easy enough to do. And that's definitely the assumption that we base a lot of our infrastructure on, and we've seen work so far. But yeah, also that communication layer that I talked about before, that between those small microservices, when you run it in a service like Lambda, needs to be easily extendable because you want to pull something out and then put it somewhere else, but you still want them to be able to talk to each other. Same thing here, not in every single part, not everywhere, but for some of them. So there needs to be that clear path from moving from these services, from these very, very high level, very abstract services into your own more complex and more controlled infrastructure. In the end, you end up with a much more diverse infrastructure than when you really start trying to control everything from the beginning and starting at a lower level. So what's really holding us back in many of the things, communication between the services is really, really, really hard. The more and more we do it, the harder it gets, and the more different services you have, the harder it is to understand those connections between each other. And that layer needs to be abstract, easy to use, and extendable, which theoretically we have a good thing there, which is HTTP.
but that also has its issues because it's hard. Like, on the one side, you need to have explicit downtime handling everywhere then. It's really hard to understand connections between services when they're talking to each other directly and you have many of them and you don't have that high level view on them. That might not be a problem, but it's definitely something that we need to work out and to attack that problem that most developers see of like, how do I even know what's running somewhere? How does that even work? But my opinion on that is that since we give a lot of that control over to that service, like AWS Lambda, they are at least able to build tools to help with that. They're able to give us more insights because we don't really control that part. They control that communication layer. So keeping an overview on the infrastructure should potentially be helpful by these services. And to really attract that dependency problem and what is happening where, which message was sent to where. That's really important. And the relationships also. Like if I send an event and then something happens and at the end some other event or something happens in my infrastructure and I don't know where that's coming from and what the history of that is because it can come from many different ways, that's really a huge issue that still needs to be solved. And the impact that a new service has in an infrastructure. That's something like firing new events, and a lot of that comes up with AWS Lambda, or services like that in the future. When I put something new in there, what will it do? And how will it impact my infrastructure? That can be done with staging environments, but not often that easy to really gain that insight and control. So now I've talked a little bit more about the services. One of the last things I want to talk about more is in terms of event-driven infrastructure. And get a lot of your opinions on that as well then. I think that event-driven infrastructure and event-driven microservices are a really interesting way to build infrastructure in the future. I think that they're underused at the moment because it's really hard to manage them. It's really hard to keep that overview on them, really understand them very well. Those very small pieces of code in an event-driven service, like AWS Lambda, are just starting out. I think that's with all like these services and not coming up, it's something that really we need to look more into and really need to understand more to have these small functions that all scales for you. For example, I mean, that's the relatively easy thing is how to create a new user and send a welcome email to that user. This is basically a background worker in that sense. I think one of the most interesting examples is in terms of infrastructure and building infrastructure, having these small pieces of code that can run whenever. Do you guys hear me still fine? Yeah. That you can run whenever a new server in AWS gets started or when somebody new gets added to IAM as a user. And while these are all examples in AWS, I think that they can be extended to many other services as well. To automatically check for compliance, to automatically notify anybody on the team when stuff like that happens, to have these kind of small event-driven things that come up when something happens in your infrastructure for an automation perspective are really, really interesting. Something that I have no idea if that's a good idea. I think it's an interesting idea. It's probably not a good idea. Is event-based HTTP, which basically an AJAX request triggers an event. Lambda functions or any small service functions collect the data in the background and send the data through the WebSocket to the client. Maybe not a good idea because it breaks the basics of HTTP, which is typically not a good idea. And most people like the basics of sending and getting a proper response back with the content. That's often really hard. But I think it's interesting. If we can build infrastructure in the future in a way where it's comprised of very small things that share events, that share communication with each other, and send something back on an event-based system to the customer, are then used with the different JavaScript frameworks, and I mean, there's a new one coming out all the time, and how we can incorporate that kind of style into building our systems in the future, where we don't have to control a lot of the underlying services, underlying infrastructure, but really only manage very small pieces of code that are mostly scaled automatically, mostly healed automatically, without us having to do really only the coding of the product. So yeah, will it become integral part of infrastructure? Will it become an integral part of the application development or even just a simple workup background tool? I think that's something that is still very open and a large question for me, and where these services are going. So that's very open. So just to recap a bit, software is totally everywhere. Software is taking over every market. Software companies are taking over every market, every industry. Productivity really wins those markets, productivity and speed. We need to be able to outsource where possible, not outsourcing labor, because that, in my opinion, really doesn't work anymore. Especially for these companies that want to be very competitive, but outsource to services, outsource the automation or to automation. And I think that we don't have a choice in that. I think that's while we like to do a lot of the things that are deeper in the stack, I think that many companies will not have a choice to do that in the future because it distracts them from building their product, and it will open up the door to another company to come in, be more productive, be more efficient, and build something faster. So I think most companies just won't have a choice. And it's something that will happen over the next couple of years or like even longer than that. But I think most teams need to understand that while it's fun to do some of that, it's probably not the right thing to do, and then just not do it. So I think that choice has been made because those services, those products like the cloud and like AWS and all that are out there, and so many people are taking advantage of it. That just has happened. Building microservices is something that is a very important topic now, and a lot of discussions, even here at the conference, are talking about that. And making sure that we have microservice services that run those microservices, something that makes it very easy, as the Heroku's in the past have made it very easy to run like simple Rails applications or simple applications, to go even a level higher and run these very small pieces of code, even smaller than before. And I think an important topic to discuss and to learn more about in the industry is how can we leave the monolith behind as the first building block? And even do we want to leave it behind? Where can we split? How can we split it up? Where can we start building those microservice or service-oriented architectures, but microservice-oriented architectures? On the other hand, other opinions are available to that specific thought if you should go away from the monolith. And in case you haven't seen that one, I found that really interesting. There was, especially for the Rails world, I know this is more of a Java conference, but there's a recipe for the world's largest Rails monolith, which is 400,000 lines of code, which is in Rails. Like they had to do a pull request on Rails to allow that in the stats, like when you run the stats and see how many lines of code you have, they had to add like another column for that to be able to have the 400,000. Like there apparently wasn't any more than 199,999 lines of code application, or nobody at least said something about it. So they had to patch that. So that was a really interesting article, how very large monoliths, and they connect when starting up to 30 different databases, which is, at least from the world where I'm coming from, totally crazy, but interesting. And at last, I want to call out for help on many on those things. I think we've undershared, as an industry, I mean, our stories and about microservices, how we build service-oriented architectures, how we even started. I think that we have this kind of survivor bias on that we hear from people at the end when they've built the infrastructure, and then they talk about how cool the infrastructure is now. But it's not really okay, now we started doing this. We started to doing a user service and pull it out of our main application, and then we start to write about it. And then 6 months later, that was the dumbest idea ever. We shouldn't totally not have done it like that. We should have totally done it differently. Those are really important to share. Those are really interesting. It's a really interesting topic, and something that is just not there enough, in my opinion, in the wider industry, in the knowledge that we share. So being able to, and if that's the one thing that you want to take out of my presentation, I think that's the important thing, is please share more about your experiences in that. And I'm definitely going to ask you more about that too. Because there's so many more open questions to explore. How we build this, how we can get started with it, how we can be more productive. It really needs to be much more of a conversation than it is now, and it's already a good level, but there needs to be more, I think. And since we have quite a lot of time still, I want to go into QA. And so there's two sides to that. I'm obviously very open to questions if you have anything specifically you want to talk about. But I also, to kickstart that, I also really would like to get some of the answers that you might have here in the room. So are you building microservices? Where do you start splitting them up? Which technologies or services are you using? And are you happy with the results? So if you have something to share for just a few sentences, I'd really appreciate if you take the time here. And I'm also happy to take any questions now. Thank you.
My name is Alex Resnick. I work for the Weather Channel here in Atlanta. We're actually combining two large monolithic applications into a microservices-based solution. And so we've been kind of concentrating on that over the last couple of months. And I think a lot of the use cases that were giving us a lot of headaches in the monolithic world have, once we moved those pieces into microservices, have kind of disappeared. Like, for example, things competing with each other, we're able to separate the systems in such a way that, the system has these resources, the system has these resources, and so it's proven to be a very successful venture so far.
Cool.
And we're hiring, actually.
Fair.
Scala, and mostly Scala engineers, but also Java engineers who are wanting to learn some functional programming. If you're interested, come talk to us after.
Just which languages? So it's mostly Scala, or?
Mostly Scala, yes. Scala, and we use not only SQL databases. I don't like the NoSQL term because a lot of the interfaces look very SQL-ish like.
Yeah.
So it's that kind of stack, yeah.
I have a question for you.
Sure.
How large is large? You have two large things you're combining. Are those Java that you're combining and converting to Scala, or are they Scala separately?
We have one large Scala and one large Java.
Okay.
And we realized that both of those need to be chopped up. And large in terms of, our, they're pretty large servers, like a lot of lines of code, but also our customer base is very large, right? So we're doing this at pretty massive scale, like 10 servers. All right, thank you.
And if I remember correctly, I think you were at the reInvent. So one from the Weather Channel was presenting there about how you guys are using AWS now, I think.
Sure, yeah.
Probably. Yeah, so in the keynote. So there was something in the keynote.
One of the things that you mentioned was that HTTP may be the wrong kind of way to talk about this. And this is a problem we're having at my company where when you have a whole bunch of little microservices, suddenly how do they know about each other? How do they know what their interfaces are? You have a direct point-to-point problem. Have you looked at things like having a more general messaging bus, much more like the way that the internet actually works?
Yeah, so I think that the way we do it, we try to not have, we don't use HTTP, really. We try to do it over queues as much as possible and queuing our messaging systems as much as possible. Something that I heard another team talk about, what they did is they basically wrote a queuing adapter between AMQP to HTTP. So you still had a HTTP server running, just an adapter for AMQP, which made the development relatively easy. But then they could just throw in, I think, Rabbit, but you could do the same with something like AWS SQS or something like that. So the important part for me is I really want to move there to a system where I don't have to manage the infrastructure underlying the queuing system as well. So I talked to a couple of people who have used SQS in the past. Some of them liked it, some of them didn't. But yeah, I think when you're able to go somewhere where you move through a queuing system, you can somehow buffer there, and not every server needs to really take care of the downtimes of others, but can just wait for a while. That at least is an interesting way. I don't know if it's the right way, and it's probably not the right way for all of the services, but that's at least where we try to go in many of the the steps. Does that cover the question? Cool. I think there was something.
Yeah. With the microservices, especially moving from like a monolith to microservice, one of the things that we keep bumping into is you could easily end up with a library or a set of code which gets copied over or pulled into the different services, right? Defeating the purpose. Like, have you run into that? What's been your experience?
So there, for example, to have like your models shared between different parts. So what it is really, I think that one of the important things that we do there is just we don't copy them, or we really try to not copy them over and build like specific classes everywhere or specific like code pieces that are only very focused on what that service does. So I think something where treating each service as its own product, more or less, really helps it with its own code base completely out there and like only share utilities, but not kind of the business code. I think that is, at least that's the approach that we're taking, and I've seen many people take, because like if you have the fat model, you don't need like all of that stuff everywhere, and like that copying or even putting it, and as soon as you like take some of it out of the model code or like the business logic, put it in a separate library, try to share it with others, then it's really hard to deploy them independently, or so that's why we really try to have like every microservice stands completely on its own. You might share a couple of utilities, but they're not business critical code. Or like they're not business code, and really just build those models for each one. And I think one of the things I think that was mentioned yesterday about microservices, having your own data store, being completely independent from everything else, and really treating them as their own product. That's, I think, a good view that we want to take.
So if you're creating different microservices that coordinate with each other, the more and more you do that, I would presume that there'll be problems where they're not dependencies, like the API or protocol changes or anything like that. Each microservice could be autonomous, and that allows a lot of productivity for each one, but then naturally the problem is, now if person A wants to change, they have to communicate with all the other different team stuff. Have you ever run into that problem, and how have you resolved that with your software development stuff?
Yeah, so what we do is we try to define the interfaces between them very strongly and have good tests to really cover those interfaces, but then deploy things independently. So I think there's two approaches basically, and we see that same not just with our system, but with people like testing on our system, where some of them like want to deploy each part individually, and they assume that the new deployment will not break the interface. And other people really want to test that new deployment in a kind of staging environment. I think it depends if you want to have more security or more speed. I think it's hard to get both there, because if you really want to try every new change you do in a staging environment and really like run through a whole integration test through the whole system, that just takes a while, and you just can't deploy that many things independently. And I've seen different approaches. We try to do like the first one, where we test a lot and we make sure, and we tell developers, like, if you change the interface, like, please tell everyone. But then you also really need to understand like the dependencies. So I think that's one of the main issues, understanding the dependencies between different services. It's just really hard. It's way too hard still. And through a queuing system, like through HTTP, that doesn't really solve the problem, because then at least with logs somehow maybe, but really understanding the dependencies and then just relying on developers not changing the interface without telling each other. That's at least our approach. That helps with speed.
Okay. I just have a reply to him. One way you can do is you don't change the service. You make a new one.
Yeah.
You just freeze. Services are frozen. And they're small enough that you can just make a new one if you need zero changes. So that basically removes that problem.
And then you actually destroy the old version that everybody's installed, right?
Once it's obsolete, nobody uses it, kill it.
Yeah, I have a couple of experiences with microservices. Like we were building a streaming application where first you need to grant a token, and then you need to get the token, and you can upload the file or download the file or something. So we split the services like lightweight, like granting a token and putting it into Redis database.
Yep.
And then the other thing is like streaming, where it's like IO bound. So there we used like a Vertex, React Java, X, Arms Java. And then on the other end, where it's token based, we just made it as like a embedded JD string MVC and all these things.
How did you deal with exactly that problem before, where you had like the interfaces between the services, or how did you just deploy them independently and like whatever, just do your stuff, or did you like coordinate through all the infrastructure when you deployed something new?
So I mean, ours is simple. Like you get a token, and you just need the token. Like the token service is writing the metadata, file metadata to Redis database, and the actual file service is kind of getting the token. It's like you just need the token and it queries the Redis database and tries to find what file you're using.
And I think that brings up a good point that we've seen as well. That with the microservices, they're typically so easy that just changes in the interface aren't that big of a deal, because it's not a big interface anyway, because you have small code, the interfaces are just very small, so it's not that big of an issue.
We would have done everything in Vertex, but I think callback held that kind of problems. So it's not easy for every developer to understand React extensions. So that's the reason we chose that all these things that we don't really care about performance, we keep it in MWT, Spring MVC style, and all these things that we care about performance.
Yeah, I agree. I think that there's typically like small pieces of the infrastructure that really need to scale crazy, and a lot that just.
But I have a couple of questions. Like, so we are using HA proxy as a software load balancer, and if the client is big enough, then they might use creating pools in load balancers and all these things. But I'm still struggling to understand how do we monitor these and report a day, like one nice UI where you get a real-time metrics of these JVMs.
You struggle with how to get the data or what to use in terms of monitoring? I mean, so we use Librado metrics. I really like Librado metrics for that. That's what we use. I mean, it depends on you. I think the Librado metrics or Datadog are really good services if you want to host them themselves, like Graphite and all that kind of stuff. Librato, Librato. I'm happy to show it to you after the presentation as well. So they are Datadog. I think that's Librado metrics was just bought, and Datadog just got $45 million funding. So both will stay around for a while, I suppose. So we like Librado, but Datadog is fine as well. And I think for us at least, a hosted service was a good solution, because then I don't have to manage Graphite.
So for the next project, we are using Spring Code, and it's really making like you can develop it in the microservices.
There was a question.
Yeah, I work with Deutsche Post. We have a lot of friction between automation. They understand microservices that's why they send us to these conferences, but we want to adopt. So we have a lot of friction with traditional infrastructure teams because of fear. Fear that they're going to lose their jobs, fear that they're going to have to lay off, parts of the infrastructure. Do you have any experience in dealing with that? Those kind of problems?
So not personally, but I've talked to a lot of people about that. I think one of the things is really understanding that you don't necessarily need, all of the people are still very valuable, especially people when you have a lot of that infrastructure that you need to manage yourself. I think separating building an internal team that acts like a product team of like, here is my infrastructure, like I'm building your internal cloud, which I think the Deutsche Post must make to a large degree, and treating that as a product company that provides an infrastructure to the development team as like a PaaS or like infrastructure as a service, and making sure it's really hard because people are very...
Well, also they're afraid of losing control, passing down automation to developers who can deploy or
I think that's...
build servers.
I think...
Afraid of losing control. And security is a big issue these days with large companies, and it's just a matter of, it's creating a lot of internal friction between teams.
I think that's where, definitely we're building something where like the team is responsible for providing an infrastructure, and then the developers can do with that, like, let's say Docker infrastructure. And you can push any kind of Docker stuff in there, and if the development team fucks it up, then it's the development team. And I think that's a lot of the problems that happen is when, and that happens, and I've seen it in small teams. Like it's not just a problem that happens in huge teams. I've seen it in small startups as well. Like, here is something that should work, And then here is the DevOps guy in the team. It's like, what is this? Like this doesn't run, but they've hit their date. And that is not limited to large companies. And I think that's setting it up in a way where the infrastructure team provides an infrastructure where you can run your stuff in, but is basically a separate product company inside of the team where those provide a service with very clear dependencies and also very clear responsibilities. So like a lot of the security stuff is done by the development team to a large degree. Of course, I mean, the infrastructure team needs to make sure that everything is there secure. And I mean, the same with Amazon, like the shared security model of like, hey, we give you something that is secure in and of itself, but if you do some really, really stupid things, then you will make it not secure.
So one thing that made us kind of easier to reduce friction was the topic of SLAs.
Yeah.
Yes, you can delegate responsibility to some of the development teams as long as they provide an SLA, to infrastructure. So then they'll know who to blame.
In the end, I think one of the things that is really that I think is most important there is setting the incentives right. Like the development team needs to have the incentive that their stuff works well, and if their incentive is just to hit the date of release, but don't care afterwards, that's the wrong incentives to set. So I think that having these kinds of SLAs, making sure something that we've changed a lot over the last couple of months is every code change that we do needs to have proper logging and proper metrics in there. And you won't get through the code review unless it has proper logging and proper metrics in there. Because if you don't have that, it hurts you later on when the code isn't properly operationalized and you can't look into the stuff. So making sure that these kinds of incentives are set right, and thinking in terms of incentives, like which incentives does the development team have? I think worked, at least so far in our team, really well. And I think that is something that, at least from, I don't have that experience myself, but from experience that I've talked to other larger companies, was to say enough. Just making sure that the development, like operations shouldn't suffer because the development team does something wrong, and the other way around. It's not like the bad developers who just make the operations lives hard. It's both ways. But incentives need to be set right, and everybody, especially to like upper management, it needs to be clear, okay, what are we responsible for and what are they responsible for? And having a clear dashboard, I think that's something that we're working on a lot as well, is clear dashboard to show everybody in the company of like, okay, what are all the metrics that we have? What is performing in which way? And it's not just about blame, but it's really about like being able to dig deep and understand like where is an issue and where do we put more resources into. I think Ken put that yesterday as well. It's when you go into an upper level, it's not about the issue itself. It's who should get which kind of resources to solve which kind of problem. And having that transparency and like where the problems actually are and sets the incentives right as well. So I guess that would be my answer.
So at my company, we have a large monolith, financial services industry. Considering some amount of splitting, maybe not to the more pure 100 lines of code where the screen kind of microservice definition, but maybe some of the verticals of the product. But when you start thinking about currently you have this large relational store, right? And the best practice, at least what we understand today, is to have a single store per microservice, right? So what happens to those relational links? How does referencing across microservices happen, like sort of at a storage layer? Are there still global identifiers across services typically that is agreed upon, or is it something else like storing URIs or something crazy like that?
So the way we do it and the way I've seen most people do it is just some kind of identifier. It can be a UUID, can be whatever, can be the user, like it depends specifically. So how we do it, like when we split or are currently splitting some of the stuff up, is just have unique identifiers per project or per build that references then another system. That's what I've seen a lot of people do. Pardon? At the entity level, you have to have like.
So a customer could have an account ID.
Exactly, and then you just request that from different services and get more data potentially.
It's just not enforced by like where a database is sort of enforced that today. It's just not enforced.
This is how the way it. Yeah. Yes, I think a lot of these things with microservices is like you lose that control, or you just can't enforce things. Like that's in a lot of ways. So it needs to, like that's why the development practices become so much more important, and things like code review and like pulling other people in when necessary become so much more important. And if anybody else has done it different or does it differently than like passing around UUID or passing around anything like an identifier, I'd be very interested to know how. But so far, I haven't really seen another way to do this. 10 minutes, okay. Any other questions?
So it seems like follow on to that question, it seems like a lot of the what's shared across the microservices is the structure of this global data store that everybody's sharing. That's going to be critical, and a change to that is going to impact all your microservices.
Or at least some of them, depending on which ones exactly have to deal with that that data. I think the interesting thing is that you have a lot of, because it's split up in so many different ways and everybody only cares about their specific data set, that you can work around a lot of these problems. Like when you have that shared data, when you have that one big database and you want to make huge changes to, or like larger changes to it, and 5 different services pull from that one database, that becomes really hard to do a change in there, because all rely on that same kind of data set. But if you split that up, maybe most of them don't. Maybe just one of them does. And I think that's, at least for us and to some of the companies I've talked to, I think a lot of the issues just don't come up, because they are so local to like 1 or 2 services when you change some data or change something like that or change some interface, because everything's so small. That it's easier to comprehend, it's easier to solve then.
Right, but now you've got a coupling between the structure of your data and the way you decompose into microservices in order to localize the impact of those changes.
Why exactly?
Well, I mean, if you want to make a change to a particular structure in your data and you want to minimize the number of impacting services, then it seems like there's a relationship there that you have to constantly be worried about.
Yes, I think that's why making sure that every service really has only the most important data that is necessary for that service's work, and to keep that data set as small as possible and the shared data set as small as possible is definitely key. Otherwise, you'll run into pain very quickly. Yeah. So I think there was one question over there first. Yeah.
I don't know if this is so much a question as it is expression of attention or frustration, but it seems hard to limit your investment in infrastructure without committing to a fair amount of vendor lock-in. You want to get started with these things, you want them to be easy. There are vendors who are happy to make them easy for you, but that comes with the price of committing maybe to more than you'd like. And a lot of this feels very immature, seems to be changing rapidly, and there's fear that you'll start down this path, take the easy way, and find out later that you're now more committed to a particular approach than you prefer to be.
Yes.
It's somewhat bewildering to know how to get started without spending all of your time on infrastructure without ending up locked in down the road.
Yeah, I think that's why. So there's definitely the levels up, especially on the architectural level. I think that's something that AWS as a product does very well. They don't lock you in with their code, but they totally lock you in with their architecture, which feels a lot nicer and a lot less, is something that you see over time and in the future. On the other hand, and that's my personal opinion, I don't think that there's, at least if you want to go to the cloud, there is just no competition. There is really only Amazon. Everything else is just not really there. Because of all the services that they provide. Like everything that is beyond, like there's EC2 competitors, there's just no AWS competitor, I think at this point. So that's why we choose it, one of the things. But I think, yeah, you totally have to be aware of how can I move things out. I think that's why having small, very non-complex services can help, where you can pull them out, put them somewhere else, but the whole automation you've built around the provider is definitely a large lock-in, and while like there is some abstraction layers with different libraries in different languages, it's still going to be a lot of work to move somewhere else. So that's definitely the case. But I think it's in many ways probably it doesn't matter for most things. I think it's really to take a hard look at which services can run there forever and they won't be expensive and whatever. That it's definitely an important judgment to make.
Oh, yeah, I just wanted to, the gentleman was talking about the database layer. I was listening to a podcast, I think they came out this morning on ThoughtWorks site, where they interviewed Neil Ford, and they talked specifically to that issue. And the title of the podcast is DevOps and Microservices Architectural Considerations. And so he talks about that, you have this shared persistence layer, and kind of how to handle that.
That was the name of the podcast, the whole podcast, or that episode? Okay. Yes.
I don't
think you can really start talking about breaking up a monolithic application unless you also start talking about breaking up a monolithic data model. I think and I would also suggest, if you're really interested in microservices, that you also investigate domain-driven design, because I think the idea of limiting your context to a microservices. So for instance, you talk about sharing data. Well, if your microservices are targeted for a very specific limited use case, you're not going to have a lot of commonalities in what things mean. So for instance, a shipping service, a customer may mean something totally different than a customer means to a order service or a payment service, right? And so you're not typically going to have one monolithic data model that supports all of those use cases, right? So you would basically say, essentially each service would define what a customer means in that context, right? And the data that it cares about and how it behaves could be very different than how a customer, quote unquote, would behave in a different context. So those sort of concepts really go hand in hand when you start talking about microservices.
Yeah, but I think arity matters, right? Like in one context, a customer might be one thing. In another context, it might be several things, or maybe not a customer, but some sort of other entity. But then it's more about how do they agree upon what that means? Because really, if it's not the customer service, yeah, you can make an argument to store some of the customer, but it's really the role of the customer service to manage that customer, right?
Well, to manage certain aspects, customer service is probably not a great service anyway. I'll probably argue, but. Right. But again, use something like a shipping service, right? So it's going to manage certain aspects of a person or a customer. It's not going to manage all aspects of it. It's only going to manage those aspects which specifically relate to shipping product, right? So there's definitely some coordination, and we talked about the unique identifier across contexts is typically how I've seen it done. And you may, for like when you have an application at a UI level, you may have to pull in data for that customer from different services based on that unique identifier. I mean, it's certainly complex. I mean, there's some issues you have to resolve, and you're right in that we're still sort of feeling our way through a lot of this stuff. But it's I think anyway, pretty exciting.
Yeah. And I think also the important part is that while it can become very complex, I think we can start with something that is still very easy, but because we've split it up in meaningful ways from the beginning, it's much easier to iterate on that. So it makes it much easier to grow the data model, to grow the infrastructure over longer term, because we have all the automation like to add another service if necessary. Yeah? Because we already deal with 5, so a 6th one will probably not be the biggest issue we have. So I think that being able to iterate faster on the data model as well as the application in Unison makes that, while it's complex in the future, makes the path there a lot easier. And there's a lot of things that we don't have to think about today that maybe in a larger data model, you try to get a lot of stuff in there because it's just really hard to change that one huge database, or a lot harder than many small ones.
Whatever complexity you add, and you do add complexity, I think you're reducing a larger amount of complexity by breaking up the monolith. I think that's, you focus on the extra complexity of the orchestrations and stuff, but you don't fully appreciate how much complexity you're also eliminating by doing that.
So I think there was one last question.
I guess I was wondering if you ever use Packer, people who make Maker and stuff, that came up to me with like different vendors and stuff, and what do you think of the future of that being useful for that?
We use Packer extensively for us. It's an awesome tool, and I think it makes sense for, so there's definitely many tools that make it easier to go into different, or to start with different providers, or like do different stuff with different providers like Packer. But you mean in the sense of how easy it is to switch between?
Yeah, because right now, I've looked into it, not used it in any real project or whatever. It seems promising to me that they're just going to add more and more, and that it's something that I could depend on for future. I didn't know if that's your opinion of Packer.
Yes, so definitely. I think there's definitely a lot more of automation coming, and it's going to get better between different services, and it's going to get easier, maybe. But then there's so much especially when you go beyond just the like running infrastructure, beyond the EC2 layer, then that becomes a lot harder. Like then Packer is really for people who still need to manage their own servers, and which for some of the systems we use, we need to. But once you go to like Elastic Beanstalk or go high or Heroku or some higher level stuff, it's switching between different providers gets a lot harder. And I think that's where a lot of the lock-in on Amazon comes. Sadly, I have to stop. This is a really interesting conversation. If you have feedback, please send, or any questions, please send me an email to flow@codeship.com, or I'm here all day. I'm happy to talk. Thank you.